All right, the final exam review. It's really long and I don't have time to rewrite everything. So I'm going to try to do the video this way where everything's already written down. I know you can see this part. I'm not sure this is going to help that much, but if you need individual help, make sure you go to the Tutor Center. Make sure you go back to the chapter reviews that these came from. For more details, but let me try to help a little bit on this. Look at the first one. It's an expression. There's no equal sign. You need to bring in your orders of operations, your PEMDAs, your please excuse my dear Aunt Sally. The please excuse my dear Aunt Sally. That has to do with parentheses. Or grouping symbols. Remember, this is a parenthesis, that's a parenthesis. We want to start with the innermost parentheses. What's going on here? So let's go find that. So that's right here. So we need to do that first. Okay, so that's where this -2 came from. And then you need to do the exponents, which is this right here. So you need to square this. A -2 times a -2 is a 4. You need to do all that and put everything back, okay? The same way it was. Don't lose any of these negatives that are in here. And then you need to multiply right there, right? So we are still in, these brackets are also parentheses. So once you distribute this -2 to the 4 and get a -8, these brackets will change to a parenthesis. So notice these brackets here, and then the negative outside, that's what this is, and now that's a soft bracket instead of a hard bracket, sometimes people call them. So this 1 here is still here, so it's 1 minus, sorry, let me clean that up a little. That's 1 minus 8, which you have to do next. That's another set of parentheses. That gets you the -7. And a -1 times a -7 is a +7, okay? All right, so the next one, orders of operations. I should have left pen to, please excuse my dear Aunt Sally. The square root of 25 kind of falls under the exponents. Either where you're squaring something or you're square rooting something, okay? So the square root of 25 is 5. And notice this is 5 times the square root of 25. So 5 times 5 is there. In the parentheses right here is 6 minus 5, which is 1. This is 6 times whatever that is. So now this is 6 times 1. And notice I'm bringing the plus side down. So in PEMDAs, you always are multiplying and dividing before you add and subtract. So we bring that addition down. We're going to multiply next, though. 5 times 5 is 25. 6 times 1 is 6. Put that plus over. And then 25 plus 6 is 31. Okay? Let's see. Add 2 mixed numbers. How do we change mixed numbers into improper fractions? There's another way to do this one too. Does anybody ever do these in the vertical method? Sometimes people do these this way. Because the denominator in the fraction part is the same, it's really easy to do this one this way. 4 plus 3 is 7. You can add the whole number parts. And then this is 9 over 7. Okay? And then 9 over 7 is an improper fraction that means you can take out a 1. So this is 1 with 2 sevenths left over. So we're going to add that 1 to the 7th, and we're going to get 8 and 2 sevenths. Okay, so that's one way to do it. Another way to do it is convert your mixed number to an improper fraction. So that would be the whole number times the denominator, so 4 times 7. And then you're going to add the 6 to it that's up here, okay? So 4 times 7, you must do first. You're going to get 28 plus 6 will give you the 34 over 7. And then 3 times 7 is 21 plus the 3 is 24. That gets you here. You add them across, that gets you 58 over 7. 7 into 58 goes 8 times, so that's your whole number. And then the 2 goes back over the 7, okay? So that's the final answer if they want. Notice there's no instructions here. Right about now, I would really like to know if they want an improper fraction, a mixed number. They might even want a decimal. 58 divided by 7. Usually, they want a improper fraction. Sometimes, if your problem has mixed numbers in it, they'll take a mixed number back out. But make sure it's the process that you understand, how to convert back and forth, okay? Number 5, 80 is 50% of what number? So this is the equation way to do this. There's a proportion way with bases and amounts. I'm not sure that I remember that way. But for me, it's easy enough to say that's 80 is. Every time you see an is, that's an equal sign. 50%, take your percent and turn it into a decimal. 50% divided by 100 gives you the 0.5. Okay, that basically you're moving the decimal place 2 places to get that 0.5. Times, and what number usually can stand for an x. So that's just 0.5x equals 80. And then you isolate your x by dividing by same. 80 divided by a 0.5 is 160. Okay? And let's see, the area of a rectangle. The area of a rectangle is length times width. This one's got mixed numbers in it, so convert them any way you want to improper fractions, so you can multiply them. I don't think adding them down is going to do you any good this time. So we need to convert them. So 5 times 2 is 10, plus 1 is 11 twos. 2 times 3, put that in your calculator first. 2 times 3 is 6, plus 1 is 7 over 2. Then your fractions, you multiply across the top to give you 77, multiply across the bottom to give you 4. It's important that we know how to add and subtract and multiply fractions. Okay, so that gives you 77 over 4. That is a reduced fraction. There's nothing. Think about the factors of 77 as 7 and 11. There's no factors in common with a 4, so that is a reduced fraction. Same with the 58 over 7 above here. That's perfectly fine to leave for an answer. Make sure you're reading your instructions on the final as to the final form of the answer. If it says it wants its answer in an integer or a fraction, that mixed number there is not an integer or a fraction, okay? That's a mixed number. So this is a fraction. An integer would be, what are your integers? 1, 0, negative 1, 2. They're sort of whole numbers or negative whole numbers, if I'm allowed to say it that way. Fractions, they're not, okay? Nor decimals. Integers do not mean decimals. So I would go with the improper fractions. Okay. Number 7, at the restaurant, the bill came to $58. If you decide to leave a 20% tip, how much do you need to pay? Round your answer to the nearest cent. If it asks for the nearest cent, that's code for give me 2 decimal places, right? $1.50 is 50. Put the 0 in there, is rounded to the nearest cent. All right, so what is 20%? Well, what's 20% as a decimal is 0.2, right? 20 divided by 100, 0.2. 58 times 0.2 is $11.60, which is your tip. Add that to the bill amount, which was $58 even, and you'll get a total of $69.60 that you need to leave on the table. Okay, that is rounded to the nearest cent, which is the hundredths place. Okay, put that 0 in there. Okay, translate. The sum of 3 times a number and 6. So 3 times a number is 3x, and is the plus. 6 is 9 more than, less than, from are keywords that mean the terms are out of order. So if the number is an x and then a 9, it's x plus 9. Now, it's not so important, mathematically speaking, when there's no negatives involved. But if this said 9 less than a number, it's really important to put them in the proper order that you need. So when I say out of order, the 9 will not be coming before the x. Okay? All right, so we got 3x plus 6 equals x plus 9, and then it says find the number. So you can't stop there. You need to go ahead and solve. This is a linear equation. We solve linear equations by getting the x on one side alone and all the constant terms or the numbers without letters on the other side. Okay, these are the variable terms and these are the constant terms. So we want to get all the x's, all the variable terms on one side. I prefer to put them all on the left side and all the constants or the plain numbers on the right side. And I kind of do it all at once. You don't have to do that. But that means I want to keep the 3x on the left, and I want to move this single x over to the other side. Now that's a 1x. If you want to put the 1 in there, you can. That is 1. Sorry if you can read this. This is getting kind of messy, isn't it? Sorry. Let me get some space here. All right, so you can put the 1s in if you want. So this is, you're going to move 1x to the left side. You move things. This is, because this is an equation, I go with distribution, combine like terms, move by adding opposite, and isolate by multiplying or dividing by same. Okay, add opposite. So if you have a positive 1x, you want to add a negative 1x to both sides. That's how it goes away from this side and moves over to the other side. 3x minus x equals 2x. Okay. Sorry. That gets rid of the x's on that side. Now, if I'm moving the x's over to the left, that means I move the constant term over to the right. So that's a positive 6 minus 6. That'll get rid of it on that side. Move it over here. Whatever I do to one side, I do the other side. Positive 9 divided by 6 is 3. Isolate the x by dividing by 2. Whatever we do to one side, we do the other side. So if I divide this side by 2, I divide that side by 2. So that gives me my 3 over 2. Okay. All right, number 9, write your answer in the lowest terms. This is a fraction divided by another fraction. So the expression that I use is keep, change, flip. Keep the first fraction as is. Okay, change the division sign to a multiplication and flip or give the reciprocal of the second fraction. It has to be the second one, not the first one. It matters, okay? So then when you're multiplying fractions, you multiply across the top, that gets you a negative 15. Across the bottom gets you a 60. Now some people reduce in place. So this is a negative 20, 5 over 3. 5 goes into 20 4 times. 3 goes in 1 time, and you're left with a negative 1/4. Now, if you don't want to do all that, then you multiply across the top and get the negative 15. Multiply across the bottom and get a 60, but then you need to reduce fractions. Okay, it turns out that 15 goes into 60. You don't have to go there in one shot. You can go through the divisibility rules. We know that 5 goes into both numbers because the last digit is a 5 or a 0. So 5 into 15 is 3. 5 into 60 is 12, and then you can take another 3 out, okay? Or you can do 15 all at once, and that'll get you the same answer as a negative quarter, okay? All right, down at the bottom here, use the rules of orders of operations. Really don't need that. It was an expression. We're still solving it the same we did up there, so we work within the parentheses first. This is just another way of saying a negative 5. Like this could be minus 5 instead of plus a negative 5. So that's a different use for the parentheses. So what we need to do here is a negative 3 plus 10 is 7. Then we need to multiply next. I think that's one of the biggest mistakes people do. Is it the same thing when you take a negative 6 plus 7 and then multiply it by 7? It's not. So we need to multiply first to get the 49, and then use your order, and then add and subtract everything, and that should get you your 38. Okay? All right, this expression right here has two fractions that you have to add. You need like denominators when you add fractions. Okay? So if you need like denominators, you need LCDs. Lowest common denominator for a 3 and a 2. Think about multiples of 3 and 2. They both go into a 6, so we can use a 6 as the least common denominator. So how do we convert the 1/3 into something over a 6? Well, it's 3 times 2 gets 6, so therefore 1 times 2 is 6. So 1/3 has an equivalent fraction. Something that equals it is 2/6. Okay? And then I need the 1/2 over a 6 as well, so I can add them. 2 times 3 gets me a 6, so 1 times 3 gets me the top. I mean, it makes sense. 1/2 is the same thing as 3/6. Okay, that's all I'm doing is making equivalent fractions. So I can add them together, get my 5/6. That way I've handled what's in the parentheses first. And then 5/6 times 5/6 is the same thing as being squared. So 5 times 5 is 25, 6 times 6 is 36. And if you can't reduce them here, you can't reduce them there. So that's your final answer. Okay, do not turn it into a decimal. They're not going to, your points are going to be taken off if you do not leave it as a fraction. Read the instructions, okay? Number 12, what is the cost of 14.5 gallons of gasoline if they are $3.20 per gallon? Right? Something costs $14.50 each. Something costs $3.20 each per, right? That's the same as each. $3.20 per gallon. You need to fill up something that's going to hold 14.5 gallons. It's just a multiplication problem, okay? 14.5 times 3.2 gets you your $4.40. Make sure you're rounding to the cents. Put that 0 in there, okay? Convert 5% to a decimal. One way to think about converting, if you had 36% and you're told to put that into a decimal form, anything percent is the same thing as a number. That's the definition of percent, is the number over 100. So you can take whatever they said and put it over 100. Once you do that, this is a division problem. 36 divided by 100 gives you 0.36. It moves the decimal place 2 places, okay? So 5% as a decimal is 5 over 100. 5 divided by 100 is 0.05, right? 0.5 is 50%. Make sure you move it 2 places. All right. The next problem, there's a couple ways to do it. This is an equation, okay? Solve for b. So you have 2 choices. You can notice that your constant term, your 2, can be moved to the other side, because if we have a variable term, our goal is to get it alone on one side and all the constants on the other, okay? If you have a single variable. So I can move the 2 by subtracting 2 from both sides, okay? That'll end up with b over -6 equals -1. So if we multiply both sides by what's on the denominator, that'll cross out, right? So you're left with b, and then negative times a negative is a positive. So that's one way to do that problem. How many people looked at it? Sorry, having a hard time writing here. And saw a fraction and said, well, I know this, since this is an equation, I can clear the fraction by multiplying every term by the LCD. So -6, -6, -6. I think the biggest problem with this method is people forget to multiply all the terms. Because it's an equation, you can't just multiply the one you want to get rid of. You need to multiply each of the terms in the equation by the same thing to keep it equal, okay? So if you do that, you're going to get b plus, let's see, 6's go away. Negative 6 times 2 is a negative 12 equals a negative 6. Then move the 12 to the other side, and you're going to get b equals 6. So either way, that works fine. 15, solve for x. We have x minus 2 plus 9. I think the easiest thing to do would be combine like terms. Remember, you distribute, you can clear, you can combine like terms. All these things have to be decided on for each individual problem. So this one you need to combine like terms first and get that to be a 7, right? These two here. And then you can move the 7 to the other side. So you get, wait, that's a plus. Okay, this is why I don't rewrite things down. Let's go back over here. Right here, I already did this, and these answers have been checked, so I don't want to be doing that again. So negative 2 plus 9 is positive 7. To move the positive 7 to the other side, you subtract 7. 3 minus 7 gives you a negative 4. Remember, you can always put back in that negative 4. If this is important thing is the final, you can put this back in, put this in your calculator, and check that. What is negative 4 plus a negative 2 is a negative 6 plus 9 is 3. So that means that negative 4 is correct. Okay, you can take the time to do that if you want. Number 16, there's your variable term right there. So that means that this constant has to be moved to the other side. Do not move this one this way. You're going to end up with something, actually you're going to end up with nothing on one side. When you're solving a linear equation, you want to put all the variable terms on one side and the constants on the other, the plain numbers on the other. When if we were still doing factoring, that's when you get 0 on one side. Excuse me. Or when there are two, if this was u squared, you want to put all the terms on the same side and get 0 on side. But remember, when you do linear problems, you don't want, that's not your goal. You want u on one side, this u on one side, and a number on the other. So we're going to move the 5 over by subtracting 5. A negative plus another negative is a negative. And then we're going to divide both sides by the negative 8. So we reduce that away to a plain u. And then don't forget, a negative divided by a negative is a positive. And then check to see if your fraction can be reduced. And in fact, 8 goes into 24 3 times. Okay? You put that 3 back in and check if you want. Now 17, people have problems with 17. Because there are a lot of letters in here. We have a variable that's a b, we have another one that's a negative d, and another one that's a positive p. So we need to go back and notice they're asking for the d, okay? Usually you're told to get that alone on one side. You don't really touch that. You touch the other ones, and the key would be to move the other ones away. There are several ways to do this one, but I'm going to do it that way, okay? So that means the negative 6 needs to be put on the other side by adding its opposite so it goes away. Okay, so now I have b minus 6, and now I want to move the p, so I can subtract that away. So that needs to go over here. So I have all them on this side, b minus 6 minus p, in any order you like, as long as the p and the 6 are negative. But then notice I still have a negative d. So we need to divide by a negative number to get d alone on one side. Whatever we do here, we have to do for each of these. So a 1b divided by a negative 1 is a negative b. A 1p divided by a negative 1 is a positive p. Negative 6 divided by a negative 1 is a positive 6. So these 3 terms can be in any order you want them to be, as long as the b is negative and the p and the 6 are positive, and the d is completely alone. Okay. Here's another one like that. It's got lots of letters. It has a Y, it has an A, and it has a B. But it also has the distribution. You need to go ahead and distribute, and don't forget to distribute to both terms. I've seen lately people just distributing that to the first. This is not the same. This does not say that. Okay? You have to give them to both terms. And then once you do, you have to go back and remember, since there's lots of variables, you need to look for the one they want. So the one they want is the B. Has to be alone on one side, not the Y this time. So we're going to take this term here with the A and move it to the other side. We're going to move it to the other side by adding its opposite. And these are not like terms here, so don't put them together. Put them side by side. And the 14A is negative. Whether it's first or second, it's got to be the negative, and the Y has to stay positive. Now, over here on this side, there's a 6 in front of the B, so we're going to isolate the B by dividing by 6. Okay, so this one divided by 6 and that one divided by 6. So either of these answers are acceptable for that one. This one looks pretty simple. I have a variable term on this side. I have a constant term on the other side. That means I want to divide by the same. I think that one's just checking to make sure you're going to divide by a negative number, because you want to get a positive t. A negative 6 divided by a negative 6 is a positive t. 30 divided by a negative 6 is a 5. This is kind of the long way over here. 30 divided by 6, you divide each side by 6. You get a 5 divided by, ooh, I dropped my negative. 5 divided by negative 1, which is a negative 5. Okay. You can just go from here to here. You don't need that step if you don't want to, but that's just a couple ways to go. Okay. Let's see. If your answer is a fraction, write it in a reduced form. If not, do not convert it to a decimal. That's like really long code for put it in an improper fraction. Okay. If it's a fraction. Definitely not a decimal. All right. So it's an equation. It's an equation. Notice there's an equal sign right there. We're still going to distribute. Okay. That's going to give me negative 7x, negative 28. Bring down the negative 5. Distribute. Gives me that. I need to combine like terms first. Both these constants to go together give me this. These are not like terms on the other. So moving on, I am going to decide to move. I personally want to move my x's to that side, so I'm going to subtract 2x to that side. You can add 7x to both sides if you want. I just have a habit of keeping my x's on the left side. So I'm going to get rid of these by moving it this way and get a negative 9x. Get rid of the negative over here by using a positive. So I'm going to come down, add these, and get 47. And then divide negative 9 by negative 9 to make it go away. Whatever I do to one side, I do the other. So 47 divided by negative 9. And 47 and 9 are both kind of big, but 47 is a prime number, I believe, so that is not reducible. That's my final answer.